Welcome everyone, and today the topic of our discussion is the discovery of neutron. You know that proton was discovered in 1886 and the electron was discovered in 1897. Until 1897 most of the properties of the electrons and protons that had been discussed. But there was a problem that the mass number of the elements they couldn't be justified, and they could never be justified until and unless a new particle is discovered. In 1920, the presence of neutron was predicted by Lord Rutherford. But in 1932, James Chadwick discovered the neutrons. He discovered neutron in 1932. And it was a big achievement. That's why in 1935 James Chadwick was awarded with the Nobel Prize. Nowadays we know that the mass number is actually the sum of number of protons and number of neutrons. And how can the mass number be justified without neutrons? With the help of only proton and electron, the mass number could never be justified. And this mass number was the base for the discovery of the neutron. Now, how the neutron was discovered? What was the experiment? The schematic diagram of this experiment is in front of you. This one is the lead block in which polonium is placed. Polonium is a radioactive element and it is an element of the group 6A of the periodic table. It was discovered by Marie Curie, and because Marie Curie belonged to Poland, so on the name of her native land, he named this element polonium. And polonium at that time, it was a rich source of the alpha particles. That's why polonium was specifically selected in the discovery of the neutron. Now, polonium releases the alpha rays or alpha particles. It is a source of alpha particles, and every one of us know that alpha particles are the double ionized helium atoms. Means the two electrons are removed and now just the helium nucleus is there. That is called as the alpha particle. When these alpha particles were bombarded or directed on the beryllium target, then the new radiations were produced. And these new radiations, when they were detected by using the charge detector, the needle of charge detector was just on zero. It means that these new radiations or these new particles are neutral in nature, and which is also shown by the word neutron. There is a question that why beryllium was selected for the discovery of the neutron. Actually, before beryllium, the same experiment was conducted with boron, lithium, and other light elements. But when beryllium was bombarded or irradiated with the alpha rays, most intense outflow of the neutron was seen. Why this most intense outflow of neutron is seen with beryllium? I am giving you a point. Because the neutron binding energy of beryllium is very low. The neutron binding energy low means its neutron can easily be made free. So that's why typically beryllium was selected for the discovery of the neutron. When the beryllium was irradiated with alpha rays, some new radiations were reported. But nowadays we know that these were neutrons. But at that time, consider that time when this experiment was being performed, these radiations were considered as gamma rays. Chadwick and other scientists, they believed that these are not some new particles, but actually these are the gamma rays. But later on, it was revealed that the beryllium doesn't emit gamma rays, but these are some particles which are, due to their neutral nature, they were called as neutrons. What were those properties that were different between gamma rays and neutrons, and because of them we could identify that these are not the gamma rays but these are the neutrons? I will discuss those properties after some time. Now, the equation is alpha particle is bombarded on the beryllium and the beryllium is changed to carbon with the release of neutron. N is the symbol of neutron. 0 mean it has no charge, it has no role in the atomic number of an element. And 1 mean that the relative mass of neutron is 1 and it plays a role in determining the mass number of the elements. This kind of reaction, these are called as radioactive transmutations. So such kind of reactions are called as radioactive transmutations. What is meant by radioactive transmutation? Mean when an element is bombarded with some radiations, it is changed into another element with the release of new radiations. This reaction is called as the radioactive transmutation. So in this way the neutron was discovered. But now let us discuss the properties of the neutrons and reveal some important points about the neutrons. Number first property, neutron is neutral. How it was confirmed? Because the neutrons are not deflected in magnetic field or in electric field. So there no deflection in magnetic and electric field revealed that the neutrons are neutral in nature. Because they are neutral in nature, they have high penetration power. They have very high penetration power because they are neutral in nature and they do not interact with any charge. Third, they can release the protons. You can use word release or knockout. They can knock out the protons from paraffin wax. Now, there are some people that listen this word paraffin wax and they are confused. What is this? This is a very common material. You know the paraffin candles, the candles which are quite common in the market, white candles, they are made of a paraffin. They are called as paraffin candles. But keep in mind one thing, that paraffin is basically a substance which is a hydrocarbon having carbon atom from 20 to 40, and paraffin is very rich in hydrogen content. So when the neutrons are bombarded on the paraffin wax, the neutron make the protons or H positive ion from paraffin wax to knock out. These are two properties due to which it was confirmed that these radiations are neutrons, these are not gamma rays. As I have already mentioned, that when beryllium emitted some radiation, it was thought that these radiations are gamma rays. But these two properties confirmed that these radiations cannot be gamma rays. How? Because number one, the penetration power of gamma rays is very less, but the penetration power of these new radiations, that was 100 times more as compared to the gamma rays. I will give you an example. Gamma ray can penetrate only to up to 2 millimeter piece of lead, 2 millimeter in thickness. They can penetrate that piece. But the neutrons can show penetration up to 200 millimeter thickness of the lead. So it means the penetration power of neutron is 100 times that of gamma rays. That's why the first point, it confirmed that these radiations cannot be gamma rays, because gamma rays do not have such a high penetration power. And second point, this one, when the gamma rays are made to fall on paraffin wax, protons do knock out, but those protons are not very highly energetic protons. But when these neutrons are bombarded on paraffin wax, because the mass of neutron and proton is very comparable, so when they strike with the proton, they knock out high energy protons from the paraffin wax. So gamma rays do not have such a high penetration power, and gamma rays cannot knock out the high energy protons from the paraffin wax. That's why it was confirmed that these radiations can never be gamma rays. These are not gamma rays. These are some new radiations. And then the work started on it, and it was reported that these new radiations are actually the elementary particles of the atom, and these are the neutrons because they are neutral in nature. Now the next one. The fourth property, that a free neutron is unstable. First of all, you must have an idea that what is a free neutron. A free neutron is the neutron which is not present in the nucleus. The neutron which is present in the nucleus, that is the bonded neutron. And the neutron which is outside the nucleus, that is the free neutron. Whenever the neutron is present within the nucleus, it is highly stable because it has huge affinity and love for the proton. But when the free neutron is there, it is outside from the nucleus, then it is highly unstable. And its half-life is 10.3 minutes. It decays. The free neutron is unstable, it decays. And how does it decay? It will be changed to a proton, an electron, and a neutrino. So a neutron, free neutron, is unstable and it gives beta decay. This is beta decay because the electrons are being ejected. So neutrons show beta decay when the free neutrons are there. Let me tell you one point which is quite conceptual. Why these free neutrons decay? Listen to me very carefully. This point is very interesting. The mass of one proton is 1.0073 AMU. And the mass of one electron is 0.000548858 AMU. When you will combine these two masses, the mass will come out to be 1.0078 AMU. But the mass of neutron is 1.00, I think so, 87 AMU. Look, that the combined mass of the proton and electron, that is much lesser as compared to the mass of neutron. This neutrino has zero charge, zero mass. Then where the rest of the mass has gone? The mass of neutron is 1.0087 AMU and the combined mass of proton and electron is 1.0078 AMU. Where is the difference? Where this difference has gone? Actually, this difference has changed to the energy. And when you can say that some energy is also released in it. So it is the conversion of mass to rest of the mass to energy. It means this process is exothermic. Energy is released And whenever the process is exothermic, the products are more stable as compared to the reactants. So the neutron is free neutron is unstable, but when it changes to proton and electron, no, they are relatively more stable as compared to this free neutron. So that's why the free neutron always prefers to be changed to proton and electron. Now the fifth property. The fifth property is the types of neutron. There are so many types of the neutrons, but we will discuss only two types of the neutron. The first one will be slow and other one will be fast. Now what is meant by the slow neutrons? The slow neutrons are those neutrons that have energy, kinetic energy, less than 1 electron volt. Electron volt is the unit of the kinetic energy and it is used when we study the subatomic particles. Fast neutrons are those having kinetic energy greater than 1.2 mega electron volt. These two values are very important and you must keep them in your mind. Now the student asks that there is huge difference between less than 1 electron volt and greater than 1.2 mega electrons. So where are those neutrons that have energy in between them? They are named as some other neutrons, and you can consult it from internet that those neutrons are given some other name. There is a list of the types of the neutrons on the basis of energy, but we are going to discuss only the two neutrons because they are important for us. Now slow neutrons are more important. Why the slow neutrons are more important? Because these slow neutrons are used in nuclear fission process. Why slow neutrons are more effective in nuclear fission process? Because they are slow and the uranium can easily capture them, and the nuclear fission reaction, that chain reaction will start then. That's why they are more feasible. Now what is the use of what is the use of these fast neutrons? These fast neutrons have two major uses. Either they are used as projectile. Free moving neutron will fall on an element and it will change that element into the other element. So that means they are used as projectile. Or they are used in the treatment of, there is biological use. They are used in the treatment of cancer. Let me discuss an case with you that when the protons are used as a projectile, suppose that, neutrons are used as projectile. Neutron is bombarded on nitrogen atom 714. This neutron is the fast neutron. And when it is bombarded on the nitrogen 714, the nitrogen is changed to boron 510 and the alpha rays are emitted. So the fast neutron strikes with the nitrogen 714, the nitrogen is changed to boron with the emission of the alpha rays. That is the projectile use of neutron. Mean the neutron is freely moving neutron that will fall on the nitrogen and some new element will be formed. Now how they are used what is their biological use? Neutrons have high penetration power, so they are used in the treatment of cancer, in the radiotherapy of the cancer. But keep in mind that those neutrons are the fast neutrons which are used here. But the disadvantage of the use of neutron in the treatment of the cancer is that whenever any area of the body is irradiated with a fast moving neutron, that area also becomes radioactive. So that area will start some nuclear reaction and some new radiation will be released from it. So this one is a disadvantage of using the neutron in the treatment of the biological cancer. Now, there is a reaction in your book that I am writing here. Copper 2965 when a neutron is hit a node. Now keep this thing in your mind that this neutron is not fast neutron, but it is slow neutron. All these points are very important and you must keep them in your mind in order to solve the MCQs. It will be changed to an isotope of copper 2966 and the gamma rays, they are released. Actually, in this case, this copper has accepted that neutron, and when it accepts this neutron, because neutron doesn't change the charge number, so the charge number will remain same, but when one neutron will be added in the nucleus of the copper 65, that will become copper 66. But this copper 66 is highly unstable, so it will be changed to zinc 30 66 and beta rays are produced. Now, these beta rays, these electrons are not those electrons which are present in the shells of the copper. These electrons are those electrons which are produced by the decay of the neutron. As I have already mentioned that the free neutrons decay through, they undergo the beta decay. So these beta radiations are not those which are present, these are not those electrons which are present in the shells of the copper, but these beta rays are produced due to the decay of the free neutron. Now what will be the charge to mass ratio of neutron? That will be 0 because the charge of the neutron is 0. If the charge is 0, your M value is 0, then how the mass was evaluated? There was a discussion about the mass of the neutron that we are not going to discuss here, but just keep in mind that it was given an idea that because neutron release very high energy protons from paraffin wax, so the mass of neutron must be equal to the mass of proton, otherwise such high energetic proton, the knockout of such high energetic proton, that was not possible. So the neutron have mass almost equal to that of the proton, and in some cases we say that the mass of neutron is 1840 times as compared to the mass of the electron. So what will be the mass of 1 mole of neutrons? The mass of 1 neutron is 1.0087 AMU. And you know that whenever you want to calculate the moles, you just change the AMU into grams. So this is the mass of 1 neutron, and the mass of 1 mole of neutron will be 1.0087 grams. I think so that this concept of the discovery of the neutron and some properties of the neutron is quite clear to you people. 1886 discovery of what? Proton. 1897 discovery of electron. Then 35 years, it was a period of 35 years to discover the neutrons, and one of the hindrance in the discovery of the neutrons was their neutral nature. So if anyone asks you why the neutrons were discovered very late, the late discovery was just due to their neutral nature. I hope so that you will find this lecture very informative for you people. Inshallah, next time we will come up with a new lecture. Till then, Allah Hafiz.